The chain of responsibility pattern is definitely an interesting one. It gives us the ability to literally chain object calls while giving each of these objects the ability to either end the execution and handle the request, or otherwise, if it can't handle the request for whatever reason, it'll simply send your request up the chain. And then at that point, the next object will have a chance to do the exact same thing. So the benefit to this approach, when it's relevant, is that the client can make a request without actually knowing specifically how that request is going to be handled. So why don't we dig in and illustrate this? So let's begin with something very, very simple. Imagine that when you leave your home, you have all of these various things that you need to check. Is the alarm on? Are the lights off? Have you locked the doors? All of these things that you need to do when you leave your house. Okay, so let's see how we could use the chain of responsibility pattern to illustrate this flow. Let's begin by creating some classes that will ultimately be subclasses. So we'll have something like class locks, and we'll have class lights, and then let's do one more. How about class alarm? Now, think of it like this. These classes are responsible for ensuring that the home is in the proper order for their given responsibilities. So this guy will make sure that the alarm is on. This guy will make sure the lights are off. And finally, this one will make sure that the doors are all locked. Okay, let's start at the top. So how can we do that using the chain of responsibility pattern? Well, it stands to reason that we'll have some kind of method called check, and presumably we're going to receive a request. So we need to make sure that we pass that through. Let's go ahead and try that at the bottom. Remember, down here would be the entry point, or the client, or the controller possibly. So let's say new locks, and then I can say locks check, and for the request, maybe we'll have a really, really simple DTO here. So we'll say home status, and this object will represent the current state of the home. And to keep it quick, we're just going to use all public properties here. So let's say, is the alarm on? True. And next one, are the doors locked? And then finally, are the lights off? And in a perfect scenario, all of these will be true. Okay, so now we'll say status equals new home status, and that is what we will pass to our locks object. And of course, remember, we're hard coding this here, but presumably that could come from a form or a database result set, anything like that. So if we scroll up, now I know that this will receive a type of home status, and we'll call that home. So we can say if the home is not locked, well, that's a problem. So I will represent that by throwing an exception in this case. Throw a new exception. The doors are not locked. Abort, abort. Okay, so that handles that scenario, but what if they are locked? In that case, we're good to go. Nothing else to do here. Well, now we need to have some way to call the next object in the chain. So once again, using chain of responsibility, here's what that might look like. We would inherit from a base class. And why don't we call that home checker? Maybe something like that. All right, so now I want to make sure that all three of these classes adhere to the same contract. And that contract is that they offer a method called check. So why don't we just add that here, like so. Public abstract function check. Now, as long as we make sure that these implement or extend the abstract class in this case, extends home checker, we can make sure that this contract has been enforced. But next, what about that thing where we want one object to call the next object in the chain? Well, why don't we place a next method directly on this parent class? Now that will expect any class of type home checker. And why don't we call that home? Okay, so now we have this method, but I still have no reference to what is essentially the successor, the next object in the chain that we should call. So before we move ahead with this, let's add another method. And in terms of naming, most books will show you something like this, set successor. But if you don't like the convention of using set, you could always say something like succeed with. It doesn't matter. So once again, we'll expect an object of this same type, and we'll call it successor. Now I can assign that to this object. This successor equals successor. And we'll set that as protected at the top. Okay, so now, whenever we call succeed with, we're going to give the object the next one in the chain that should be triggered. So that means when we call next here, and by the way, that should be home status, not home checker. Anyhow, when we call this method, all we have to do is say this successor check, and then we pass through the home object. I hope that makes sense. And if it doesn't, when we start writing the client code, I think you'll understand it a little bit more. So now that we've implemented this, if I go back to locks, if the doors are in fact locked, we have nothing to do here, so we can defer to the next object in the chain, like this. This, next, and we pass through the home status. So let's go through what happens here. Well, we defer to the successor object that we set, and we call that check method again. And remember, because we declare that each of these objects must offer a check method, we have 100% assurance that this method will in fact be available. So now let's just do the other implementations a little bit more quickly. For lights, we just have to make sure that the lights are off. But if they're not, well, that's a problem. So we'll say the lights are still on. But once again, if the lights are off, then we defer to the next object in the chain, if there is one. And that's an important concept. If there is a next object or ring in the chain, we want to trigger it. So that means let's go back up here and make sure that we do have a successor. Only on that condition will we call it. All right, so we have locks, we have lights, and finally, the alarm. If the home's alarm is not on, well, we'll say the alarm has not been set. And that's it. Our implementation is done. So now let's refer to our execution right here. We have our lock object. Let's do another one for the lights. And then one final one for the alarm. Now here's the key. We need to make sure that we set the successor on each object, like this. Locks succeed with lights. And then if I duplicate this, lights succeed with alarm. That's how we create that chain. So when you see stuff like this, compare it very much to a chain. We are hooking up the next ring in the chain. Then, in order to set everything in motion, and by the way, why don't we inline this just to make it a little bit more clear. Once again, to set everything in motion, all you have to do is call, in this case, a check method on the first object or ring in the chain. So before we make sure this works, let me just run you through the whole cycle. First, we set up our objects. Think of these as different ways that we can handle the request. But now if you're thinking, well, isn't that what the decorator pattern is for? Actually, no, they are similar. And in fact, when I was first learning this, that was my first thought as well. But the most important thing to understand is that with the chain of responsibility pattern, any of these objects have the ability to actually slice through that chain so that nothing else gets triggered. So that's an important distinction. Anyhow, we set up each ring in the chain, and then we hook them together, and then we call a check method on the first ring or object in the chain. So let's see what happens there. If we go up to locks, well, we pass it the status of the home, which we represent with a simple DTO. And we say, if the home isn't locked, well, that's a problem. So we will throw an exception to make sure that you do turn out those lights. However, if the home is locked, well, let's then defer to the next object in the chain. So what would be next? Well, it looks like we succeed locks with lights. So now, when we call the next method right here, we make sure that we do have a successor. And if we do, we trigger that same method on the new object. So now let's take a look at lights. If the lights are not off, that's a problem for us. So in this case, we represent that with an exception. But once again, if the lights are off, well, let's once again defer to the next object in the chain if there is one. So if we scroll down, it looks like we succeed lights with the alarm. So once again, if the home's alarm is not on, then we throw an exception. But once again, we still have this call to next. And that's why it's really important that we perform a quick check. Because in this case, the alarm does not have a successor. So if this conditional wasn't here, an error would of course be thrown. All right, so we've gone over it. Why don't we test this out from the terminal? Now remember, in this case, we are assuming that we've done everything correctly. So that means if we run this from the terminal, we shouldn't get anything. No exceptions were thrown. But now let's say that the doors are not locked, which we will represent with a Boolean. Well, we run it, and we get an exception. The doors are not locked. All right, so let's say the doors are locked, however, the lights are not off. Well, we run it again, and now we get a different exception. Hopefully you're seeing how this works. And then finally, let's say the alarm is not on. We run it, and now we get the third exception. But also, we can mix and match. So let's assume that we just didn't do anything at all. Well, now when we run this, we will basically abort immediately. But as we fix these, it will continue on to the next ring in the chain, and then they will have the opportunity of either handling the request or deferring to the next object in the chain. All right, and really, that's all there is to this pattern. It's really not the most complicated thing in the world. Really, this abstract class here is sort of the bulk of it. We need to make sure that each class has the option of handling the request. So you perform some kind of check that determines, is this something that I can handle? If it is, then handle it, and we will never execute anything else within the chain. That's what makes this unique. However, if it can't handle it, then it defers to the next object in the chain. And now in this case, lights will have the opportunity to handle the request. If it can, it does, and if it can't, it defers once again. So that's why it's vital that for every single object, you specify what its successor should be.